So let's go to combustion chemistry. Basically, a combustion is a sequence of chemical reactions involving a fuel and an oxidant. So you can see here the combustion triangle. For combustion to proceed, you have to have the fuel in the presence of oxygen and heat. It would support combustion. Otherwise, if one of the legs of the triangle is absent, it will not continue on. It's accompanied by the production of heat, as I said, and it's exothermic in nature. It involves conversion of a chemical species. So the carbon would either convert to carbon dioxide for complete combustion or carbon monoxide for incomplete combustion. H2 converts to water vapor, and then sulfur and nitrogen in the fuel may be partially or completely converted to their oxides. So SO2 or SO3, NO2 or NO3, depends on what is being stated. Energy produced is used to sustain physical and chemical changes in the process industries, just like here, coal being combusted, it's in order to produce electricity energy. In here, the fuel, gaseous fuel, being combusted in combustion engines to provide us energy to run the cars. So fuels are substances containing stored chemical potential energy, which is released via complex chemical reactions. It's classified as gaseous, liquid, and solid. And in here, fuels may contain chons, carbon, hydrogen, oxygen, nitrogen, and sulfur. So, ito yung pag-alala ko ng chons. And then, yun na nga, di ba? Mixing turbulence, temperature, and contact time, it will yield heat, these products, and the impurities as well. So this is the oxygen comes from the air. So gaseous fuels burn at their normal state in the presence of sufficient air. Liquid or solid fuels must be gasified prior to burning kasi in itself, kung liquid siya, hindi naman siya magbaburn. Yung solid, it won't burn. It has to be gasified. So it has to be at a certain temperature first. That's why initial heating is required to gasify. So what are the requirements for an efficient combustion? Remember the three T's: time, temperature, and turbulence. So it needs a sufficient time and then needs a certain temperature high enough for it to support combustion, and it has to have air, the thorough mixing. So oxygen is one of the oxidants that we need for us to completely burn. But of course, usually oxygen is supplied in excess so that it is assumed that if it's supplied in excess, it will try to drive the reaction to completion. Kasi we don't really want carbon monoxide to be forming. That's why nagsusupply ng excess air. So composition of clean, dry air near sea level. This is also important to know this, guys. Why? During my board exam, I remember, I think helium was the one being asked sa akin. So, the most is nitrogen, followed by oxygen, and then argon, and then carbon dioxide, roughly 400 ppm, and then the rest. So the products of combustion, as I said, C forms CO2 or CO, H forms H2O. The N typically does not react the N2, but this N, especially if it's present in the fuel, so N as N2 present in air typically does not react, but at high enough temperatures, 1,600 degrees Celsius, it forms NOx. Ano yung NOx na yun? NO, NO2, N2O4, or other combinations. Sulfur in the form of SO2 during combustion, it also forms SO3. And SO3 is very problematic. Why? because the formation of SO3 supports the formation of H2SO4. So sulfuric acid, if it forms on the combustion lines, it can cause low temperature corrosion. As I said earlier, combustion reaction is exothermic in nature and it produces heat. So flue gas, what is flue gas? It's also known as the exhaust or the stack gas or the product gases. So constituents of the flue gas are CO2, CO, water vapor, nitrogen gas, and the unburned oxygen, yung unconsumed oxygen. Also, it could have the impurities, the NOx, the SOx, hydrogen sulfide, some other hydrocarbons or volatile organic compounds, and sometimes hydrocyanic acid, sometimes ammonia, sometimes hydrogen halides, and sometimes the impurities such as ash or iba't iba pang solids. In order to analyze combustion, it was first developed by Louis Hengist Orsat. So basically Orsat. So when you say Orsat analysis, it's understood to be a type of flue gas analysis. But Orsat analysis, it's a dry analysis. So Orsat apparatus contains the following: a graduated burette, itong A. So alam mo yung mga measurement ng gases, three-way stopcock. So asan yung mga ayun? Para ma-close siya. And then, andito, yung mga stoppers din. So moisture present in the flue gas is removed as it passes the glass tube containing a hygroscopic material. So the calcium chloride absorbs the moisture. That's why the Orsat analysis is an analysis where moisture is removed. It's a dry analysis. So it's otherwise known as moisture-free analysis. And this one kasi, it's basically just stating what the components are of the Orsat analyzer. The D1, the D2, the D3, what do they contain, so that they would react to each of the components to yield different readings. The flue gas analyzers, it would give you the CO, CO2, the percent excess air, and then the pressure. So those are the flue gas analyzers. So what are the reactions? Ito yung fuel containing CHOS. Kasi di ba, CHONS dapat siya. However, nitrogen at times don't react. Right? Only at high enough temperatures. So C would form CO2, H2 would form H2O, and S would form SO2 for complete combustion. So hindi natin nilalagay yung CO, hindi natin nilalagay yung SO3. S plus O2 yields SO2 in the complete combustion. So guys, look at this. If you have a fuel, W, X, Y, and Z are the subscripts, the numbers, di ba? The coefficient subscripts of C, of H, of O, of S. So in here, what happens is 1:1 yung C and H, C and O. So if W rin, yung H natin to form H2O, di ba this is O2? Eh di ba, ito dapat H2, ito H lang. So 1/2, i-divide pa natin ng 2, that's why it's 1/4 of the X. Kasi this H is just HX eh. This is H2. You understand? Kaya ito magiging 1/4 siya. S, 1:1 siya sa oxygen. That's why, diba? Ito, Z lang siya. So, naka-add silang tatlo. However, bakit may minus O2? Kasi, of course, before it consumes the O2 in the air, if your fuel already contains sum of the oxygen, ima-minus mo yung amount ng oxygen na kailangan. Again, bakit naka-divide ng 2? Kasi this is simply O, this is O2. Or sometimes, ang ginagawa na lang natin, W amount of CO, 1/2 of H2O, and Z amount of SO2. For the incomplete naman, you know that it forms CO. So CO further reacts with oxygen to form CO2, right? So ito, look at this. If you have fuel carbon, you have air, O2 and N2. N2 does not react, it's still there. The O2 reacting with carbon would form either CO2 or CO. But eventually, if you have excess oxygen and the conditions are right, the CO would react to form CO2. Even with high excess air, CO and organics are still formed. Kaya nga sabi ko, it's still formed. However, if there's still excess oxygen reacting with this and the conditions are right, it can form CO2. So what is theoretical oxygen? Ito, please read the differences in here. What is theoretical oxygen? It's the amount of oxygen required to be supplied in a process for complete combustion. Theoretical oxygen required to burn a given quantity of fuel does not depend on how much is actually burned. So what it depends on is, ano ba yung kailangan kong i-burn? Okay, ang theoretical oxygen ko is based on what I'm burning, not on how much is actually burning. And then the fuel may not react completely and it may be partially burned to form CO and CO2, but the theoretical oxygen is still that which would be required to react, di ba? And can be determined from a balanced chemical equation. So, yung kaninang nakita natin, ito, W, so parang ang coefficient niya, 1, 1/4, 1 minus 1/2. So look at that, 1, 1/4, 1. Pero ito kasi O2 ito eh. Di ba? Kaya kung may O2 din, 1:1. Pero if this is based on O, 1/2 of O. In here, moles to, pero this one is mass. That's why look at this. Mass divided by 12 for carbon. Mass divided by 4. Bakit 4? Kasi mass of hydrogen is 1 times 4. Kaya 4. Mass of sulfur is 32. Eh di ba ang oxygen 16 times 2 kaya 32 ito. Kasi O2 siya. So molecular balance, the theoretical oxygen is basically the number of moles of fuel times the coefficients of oxygen in each of the balanced chemical equation. Okay, let's continue. So you already know, guys, the theoretical oxygen. There's what you call theoretical air. Air that contains the exact amount of theoretical oxygen is the theoretical oxygen. And then you've already known this, that air contains 79% by mole nitrogen roughly, and roughly 21% by mole of oxygen. And that the average molar mass of air is 29 grams per mole. All right. So let's go to, again, the concept of excess air and excess oxygen. Theoretical air, take note of this, is not enough to attain complete combustion. And then again, the indicators of of incomplete or partial combustion is the presence of CO, H2, soot. Ano yung soot natin ulit? What's the soot? Would you know what that is? Yes, that's carbon. You know how sometimes when you're burning candles and then yung top ng candle mo parang nasa loob siya ng isang lalagyan. Di ba yung top doon ng flame natin, minsan nagda-darken yung pinaka ceiling or kunyari kung container, yung ceiling ng container. That black powdery material is what you call the soot. May smoke, may unburnt combustibles as products. Excess air must be introduced to increase efficiency of your combustion process. But too much excess air dilutes the combustion gases, which results to lowering the temperature of the gases. Ayaw din naman natin nun. Because why? The reason why we're doing the combustion, di ba, is for us to attain a certain amount of energy. Pag sobrang taas ng excess air natin, bumababa yung temperature. Di ba kailangan natin yung temperature na yun to heat, let's just say, to heat yung steam natin, di ba? So how do you calculate the percentage excess air? The excess air is parang yung ginagawa natin sa basic stoic natin. Fed minus Theo over Theo o kaya Fed minus required over required. Meron din tayo isang formula. The amount of O2 fed is theoretical is equal to 1 plus the percentage excess over 100. Ito, madali na ma-solve ito nasa ilalim. Pero please take note of the ones on top. As such, the amount of N2 fed from excess air is N2 fed is O2 fed times 79 over 21. Ganun din dito. Ito please take note. The theoretical air required to burn a given quantity of fuel depends on how much fuel is fed, not how much is actually burned. Parang yung kanda natin, wala tayong pakialam, di ba? Ang theoretical na kailangan natin, it's always based on ilan ba yung given. Also, for combustion efficiency, what you call air to fuel ratio or AFR. It's basically the mass of air used in the combustion per unit mass of fuel. So air to fuel ratio is mass of air per mass of fuel. Sometimes meron tayong tinatawag na lambda. It's the ratio of the actual over theoretical AFR. Rich fuel mixtures have lambda less than 1. Lean fuel mixtures have lambda greater than 1. Ano ba yung ibig sabihin ng lambda? Ito yun. Nandito. So look at this. Sa taas, the air to fuel ratio is 12.6 is to 1. Yung lambda mo is 0.86. So that means this is maximum power siya. Diba? Ayan no? Fuel rich. Medyo ayaw natin dito kasi napakaraming fuel. Siyempre, maraming power. Diba? Kaya yung consumption, itong nasa ilalim, consumption. Yung consumption mo, mataas din. Whereas kapag ka dito, look at this, ito yung pinakamababang fuel na ginamit, pero certain power, nare-reach na niya. So you'll notice na this one will always be the maximum power, pero of course, mataas din yung consumption. Here, it's a bit lower, pero very, very low yung consumption mo. Okay? We also have what you call the equivalence ratio. Ang equivalence ratio lang naman, 1 over lambda. Okay, please take note of this. So, going back, flue and stack gas, di ba, they are the exhaust gases. So look at this. The different ways in which we express our flue or stack gas analysis are as follows. Pagka CO2, COO2, and N2, this is what you call dry flue gas. Na dry flue gas na SO2 free basis. Ito naman kapag ka included, ito sorry, I'll write it here. Dry flue gas that SO2 free basis kasi walang SO2. Pero if the dry flue gas contains SO2, it's the ORSAT analysis. Pero of course, if it's the complete flue gas analysis, it contains water vapor and the others.